Hi everyone, it's Coach Fred here, and today I'm going to be talking about composition of functions. We have started to work with this a little bit, but I wanted to really draw your attention to the notation because it looks really funny. So if you look here, this is actually some of the notation that we would use for a composition of functions. It looks like the word fog of x. This does not mean multiplication. What it actually means is f of g of x. F of g of x. So in reality, when we're composing functions, we're putting one function into another function. And I could change the order around and say gof of x or g of f of x. And that would mean we are putting the f function into the g function. Now I know that really looks funny, but I really want to make sure you understand that that is not an operation of multiplication. That is not the multiplication symbol. Multiplication would just be a dot, which you will see. We can see, remember, f of g of x, which means f of x times g of x. All right, so let's take a look at it. Here's an example. If we want to find the composition of a number, meaning find f of g of 3, think about it like this, f of g of 3. Those mean the exact same things. Okay, so what does that mean? Well, we're going to evaluate g of 3. So we're going to plug 3 in for x, we're going to square it, and we're going to get 10. All right, so g of 3 is 10. Let me write here, I'll write that here. So g of 3 equals 10. Okay, so then I want to find f of 10. So f of 10 would be 5 times 10, so 50. So that equals 50. So f of g of 3 equals 50. Okay, I want you to try it on your own, press pause, and then come back. All right, so you've tried it. You pressed pause, you plugged g into g of x, or you plugged 2 into g of x, getting 8, because 2 squared is 4, 4 times 2 is 8, and so then you looked for f of 8, which would be 24 minus 2, so 22. Okay. So with numbers, composition of functions is actually pretty self-explanatory. You're plugging one number into the function and then evaluating it and getting another number to plug into the function. But when it's a variable, it does get tricky. So we can actually compose functions using variables. So if I wanted to find f of g of x, remember I could write it like that. That means take the g of x function and plug it into the f function. So I'm going to take f at x squared plus 1. Okay, so I'm just going to plug that in to f. So that would be 5x squared plus 1. I would simplify getting 5x squared plus 5. Now, remember composition, you're putting the inside in first, so the order actually does matter. So if I were to try g of f of x, that would mean I'd want to find g at 5x. So I would put 5x into the g function, I'd square it, and then I'd add 1. So that would give me 25x squared plus 1. All right, so what I'd like you to try, we had gone over the basic function operations from addition, subtraction, multiplication, division, and now composition. So I'd like you to try the problems at the top of the next page. It's page 16. And then I'd also like you to review for your March exam by going through and matching the graphs, because these are all the parent functions that we've learned or discussed this year, and you really need to know what their basic features look like and how they look different based on the function. All right. One other thing I'd like to talk about is when we look at tables, because remember the rule of 4, we could look at it as an equation, as a graph, as a table of values, and even in words. So on page 17, page 17, you'll see that we have a table. So if I try to find a composition of functions using a table, I have to start by finding g of 8. So I'm going to look at 8, find the x of 8, and go to the g function, which is 4. So then I'd want f at 4. F at 4, I'd go to x, and then the f function, which would give me 4. I'll do one more of those. F of g of 5. So I want to go to an x of 5, find the g function, which is 8. So that tells me I want f of 8. F of 8, I go to 8 on x, and I find the f of 8, which is 9. Okay, I want you to try g through L. So that's how you'd use composition of functions with tables. All right, how do we use it on a graph? Again, we have to be able to look at this graphically as well. So here I've got two graphs, F and G, both labeled carefully. Let's try M. All right, so it says find F of G of 3. So I'm going to go to the G function and the X value of 3 and find the Y, or find the Y value, which is 4. So that means I'm going to be finding F of 4. F of 4, so I'm going to go to X of 4 and find the Y value, which would be 0. So that would give me F of G of 3 would be equal to 0. All right, so that's how you use composition of functions with both equations, table of values, and graphs. I'd like you to try the remaining problems on this page and the word problem. So let's look at this first word problem, okay? So we're on page 18 now. The function d of p gives the number of items that will be demanded when the price is p. So this is the demand function. At a price of p, okay? The production cost, so C of x, is the cost of producing x items. So C of x is the cost function. And x is the number of items. Okay, so to determine the cost of production when the price is $6, you would do which of the following? So I'd like you to think about it, and then I'm gonna give you press pause. All right, so if we think about this, we want to get the cost of production. So my output needs to be the cost function, which would tell me my outer term, my outermost function needs to be C. Okay, so these two are out. So it's either this one or this one. So if I plug in the demand function, if I plug in the price of $6 into the demand function, I'm going to get the number of items that will be demanded, okay? So that result is going to give me the number of items, which I then plug into the cost function to get the cost. So my answer here would be B. All right, so then I want you to try the remaining problem on that page, so number 9. In class, we're going to be working on writing composition of functions from word problems, and I'll do that with you directly, okay? Hopefully that was helpful. Have a great day.